So hello everyone, John here. In this video we're going to find the values, some values of sine theta and cos theta for some angles like 0, 30, 60, 45 and so on and so forth up to 2 pi, which is 360 degrees. And basically you can do this always by using the general method that we talked about. For example, you have a dynamics of, you have a basically a coordinate system like this, and you have some angle, for example 2 pi by 3. You want to know the sine, cos, tan, cosecant, secant and cot 2 pi by 3. So first you need to know where 2 pi by 3 is in your coordinate system, the terminal side. So 2 pi by 3 is basically, you know that 2 pi by 3 is greater than 90 degrees or greater than pi by 2. So if this is pi by 2 and this is 0 and this is pi, then 2 pi by 3 has to be, because 2 pi is basically, this is 2 pi, sorry, 2 pi. So 2 pi is 360 degrees. 360 divided by 3 is 120. So 120 is basically in the second quadrant, is over here. So this is basically 90 plus 30 degrees would be basically 120 degrees, which is 2 pi by 3. So if you just this would be your 2 pi by 3, because this is then this would be 2 pi by 3 degrees, because this is 90 and this is around, for let's say 30 degrees, and then this would be the rest would be up to 180 would be pi by 3 or 60 degrees. So then 2 pi by 3 plus pi by 3 would be 3 pi by 3, which is basically pi, and this is this here. So now 2 pi by 3, you want to find sine, cos and all the other trigonometric ratios of 2 pi by 3, and this is the terminal side of this of the angle. Now in order to find that, we basically need to use the method that we talked about there. What you need to do is just take any point on this terminal side, and then according to this would be the x value from here to here, which is a negative value, and this would be the y value from here to here, which is a positive value. So this would be x and this would be y. You could write x here as well, but it's basically the same thing. This is the distance is basically important. Now you have a triangle over here that has some values, and then if you're able to measure these values over here, then you're able to find all the trigonometric ratios related to that. So let me try to just draw this triangle using this color. Oops. Okay, so then this is pi by 3, this angle. So then what you need to do is basically you draw all the figure and everything that's related to the whole thing, and then you can read the values over here, and the values that you would get if you drew everything up, I mean to scale, you would get a 1 over here as your x value, and you would get a root 2 of 3 here as your y value, and as the and this would be your point P, and your point P would have the x value minus 1, because this is 1, the distance is 1, so you would get the minus 1, and you would get a y value of root 3 over here. So root 2 of 3, and then you could basically calculate the r value over here. You could use the distance formula, which is, let's call this point O, and then OP would be root 2 of basically x2 minus x1. No, I don't remember the formula. Y2 minus y1 whole squared, I guess, plus x2 minus x1 whole squared, I suppose. Let's see if that works. Now if we say y2 minus y1, let's take this point 2, so y2 root 3 whole squared would be 3, and then plus x2 minus x1 would be x2 is minus 1, so minus 1 whole squared is 1, so then you would get root 4, which is 2. So this would be then 2 again, and this is correct. So let me delete these so that so then you would get a triangle like this, and then you can basically calculate everything that you need to calculate over here. So then again, sine 2 pi by 3 would be equal to y divided by r. This is your value, and now you know the values here. The values are, let me write them in this color. So your y value is root 3, root 2 of 3. Your x value is 1, and your r value is 2. Oops, sorry. Your r value is 2. So now you know everything that you have everything that you need. And so you can calculate everything. Sine 2 pi by 3 is basically, we said that it's y by r, and which is root 3 divided by 2. Now cos 2 pi by 3 is equal to x by r, which is 1 divided by 2. Now tan 2 pi by 3 is equal to sine 2 pi by 3 divided by cos 2 pi by 3. Which is root 3 by 2 divided by 1 by 2, which is basically root 3. But you could also say that tan 2 pi by 3 is equal to basically y divided by x. You could say y divided by x, and y divided by x would be root 3. So let me draw a line over here. So now then, in order to calculate the rest of them, you have, for example, cosecant 2 pi by 3. Because you have already calculated sine 2 pi by 3, you can simply write 1 divided by sine 2 pi by 3. Sorry. So sine 2 pi by 3, which is right here 1 over root 3 by 2, which would be equal to 2 over root 3. And the same thing happens here again. The reciprocal of cos 2 pi by 3 would be secant 2 pi by 3. So secant 2 pi by 3 would be equal to 1 divided by cos 2 pi by 3. Which is equal to 1 over 1 by 2, which is 2. But I guess we have made a mistake over here. Oh, right. Here we have made a mistake. Basically the x value here is -1. I'm sorry. I made a mistake here. The x value is -1. So wherever you have x, you have to -1 by 2, and then here you get by tan 2 pi by 3 is y by x, so root 3, so this is minus root 3 basically, because it's in the second quadrant, and it's 1 by, that is correct. So sine is root 3 by 2, cos is -1 by 2, tan is minus root 3, and then cosecant is 2 by root 3, and secant is 1 over -1 by 2, which is -2. Sorry. -2. And then you have cot 2 pi by 3, which is equal to 1 over tan 2 pi by 3, which is equal to 1 minus 1 over root 3. This could be written also as minus root 3 by 3. If you